This is Knowledge Engineering with Semantic Web Technologies, lecture number 5, Ontological Engineering. In this part of the lecture, we want to talk about ontology alignment. So what is ontology alignment? Simply imagine you have two different ontologies and you try to find similarities because you want to map them. Two applications talking together must understand each other, so they must reach some communication and some understanding. For this, ontology alignment or ontology merging is the process that we want to talk today. Okay, but first of all, let's keep in mind that ontologies are not the reality. They are only a description of the reality, and for this, of course, they are always in the eye of the beholder. We have talked about that already when we have introduced ontology. So ontologies are so-called context-dependent projections, so they are a model of the reality. And always if you model the reality, you know this maybe from model theory, only you focus on the aspects that are necessary or important for the application you have in mind. So the model is never the reality because you leave out aspects of reality. And simply because of that, different ontologies might represent the same or rather similar knowledge. So ontologies, for example, might reflect different tasks and requirements for the applications that are involved with these ontologies, or they might follow different conventions or restrictions. So first of all, why have I chosen this strange old picture in the background? Yeah, this is a picture of Hans Holbein, the younger, and you don't see it on that picture, so because you don't see the picture in its entirety. But Hans Holbein has encrypted something in that picture that you only can see, not if you look at the picture from the front, but you have to look at the picture from the side, and you have to look what it's on the ground. So this is some tasks you have to do offside of the course. Here is the link to the Wikipedia page of that picture, and then you might find something which is of course also open for interpretation, and it also depends on your world knowledge, on your view of the world, how you or what you make out of that symbol that has been introduced in that picture. So therefore it fits to our topic today, to ontology alignment and ontology matching. Okay, so let's first talk about how can ontologies differ. Okay, like in language also, the same term in an ontology might be used to describe different concepts. So like for example, an author can be used as the writer of a book, but also as simply the creator of a kind of document, which not necessarily has to be a book. So these are different concepts, but you might name them in an identical way. So simple name matching sometimes might be misleading, therefore. And like in language, also sometimes different terms might describe same or similar concepts. So if you, for example, take into account author and writer, then for example, for the writer of a book, it might reflect the same concept. So like in language, if you describe your ontologies, if you give names, for example, labels in your ontology, and then if you try to map two different ontologies based on the labels, you might run into the same difficulties that you have also already on the language level. But it can be more complicated. So for example, by creating your ontology, you might follow different modeling conventions and paradigms. Just think about time. So you might model time on the basis of intervals, let's say 1 second, 1 hour, 2 hours, 3 hours, but you might also somehow represent time in terms of time points like 1 o'clock, 2 o'clock, or the 5th of November. So you might describe temporal aspects in a different way, depending on your modeling paradigm. But nevertheless, they can be compared, but you have to find the right mapping rule for two expressions following different paradigms here. And this, of course, is only an example. This might also happen in complete different domains. Then, of course, there might be in the representation and modeling a different level of granularity. So, for example, if you are looking at literary genres, somebody might have the class fiction, while in another ontology, you might find the class political fiction, science fiction, romantic fiction. So on the one hand, for fiction, it's much more general. On the other hand, in another ontology, you have more specialized terms, more specialized classes. So also these have to be matched because they belong somehow together. There is a relation between the two of them. And then, of course, the ontologies might have different coverage, or they might follow different point of views. The authors might have different intentions, so therefore modeling and representation differs. But we will see what can happen there. So there are many, many possibilities how ontologies might differ. But these differences, they can be categorized. So here is a categorization of the so-called heterogeneity of ontologies. On the most simple level, we have the so-called syntactical heterogeneity. And this happens usually, for example, when ontologies are represented in different representation languages. And this can many times be simply resolved on the conceptual level by preserving all the semantics. So, for example, if you take into account you have two ontologies, one is represented, let's say, in OWL DL, and the other one is represented in first-order logic, then, of course, you might find a mapping between the two. You might translate them, and you might preserve all the semantics that is in there. Then also you have the so-called terminological heterogeneity. What is that? So this is also quite simple. So here we have naming differences for the identification of the entities in different ontologies. And of course this might occur, for example, the easiest way is if two ontologies, for example, have been created in different languages. The one has been created in English, the other has been created in French. And then, of course, the mapping cannot simply look at the names. There must be a terminological mapping. So this is a terminological heterogeneity. And this might also be solved rather easily. It's getting more complicated if you are going to the conceptual, to the semantic level, and if you look at differences there. This means ontologies model the same domain, but they model it in a different way. And of course, this might be really difficult because these two ontologies might have a different coverage, they might have a different granularity, they might represent the domain from different perspectives. So therefore, both ontologies might represent the same domain, but they are structured in a completely different way, and therefore you have to find a mapping for them. And the most difficult heterogeneity is then on the next higher level of abstraction. It's on the pragmatic level. So we are looking at so-called semiotic or pragmatic heterogeneity. And there you take, of course, into account the interpretation of the domain, how it is modeled by some humans. So for example, you have a surgeon, and on the other hand, you have a priest, and both try to represent a human. So they have a complete different point of view, a complete different perspective, a complete different interpretation of what they are trying to represent. And therefore, of course, this is rather difficult to handle if you have differences on a semiotic or a pragmatic level. Okay, so these are the different kind of classes of heterogeneity, classes that exist among ontologies and that we have to cope with in ontology alignment. So overall, yeah, you see here on that cartoon, all of these three, they are saying the same thing, but of course they are saying it in different ways, in different representations. And now the question is, how can we align them? And of course you might, as some kind of homework, find out to which kind of heterogeneity class this kind of difference, of ontological difference, might belong to. Okay. So let's talk about ontology alignment. Of course, we have to somehow formalize the alignment process. Alignment also is referred to as ontology matching, and it's usually the process of determining or creating a mapping or so-called correspondances between ontological concepts. And it follows the simple process. You can formalize it in the following way. So we start with two different ontologies and we have some kind of input alignment. And this is the input of the matching process, which also takes into account some models, like, for example, a weighting of parameters or thresholds that have to be considered when trying to create a matching. And on the other hand, there are also external resources that come into play, like, for example, a dictionary, thesaurus, or a common knowledge basis, rules and that are available. And they guide or help and support the mapping and matching process. And in the end, the output then here is an alignment, which is called A prime. And this is a set of correspondences, of mappings between single ontological concepts in these two ontologies, O sub 1 and O sub 2. So now let's have a look at the correspondences, or at the mappings. So given two ontologies, O sub 1 and O sub 2, a mapping or a correspondence among entities E sub 1 and E sub 2 from respectively these two ontologies is defined in the following way. It's defined as a tuple, and it's a quintuple here. So this consists of the following components. So first of all, we have a unique identifier. Simply, we want also to be able to address this correspondence or this mapping. So this might be, for example, also a URI. And then we have a mapping relation. In the most simplest way, it's an equivalence between two concepts, E sub 1 and E sub 2, so equivalence between two entities. But it can also reflect a hierarchical relationship, so that it says it's greater than, or it's more general, or it's less general than. It can also express a disjointness. It can express a part of and all the stuff. So you have a relation, which gives you the relationship between the two entities that you want to map on each other. And then in the end, you also give to this relation some kind of confidence measure, because usually you cannot always be 100% sure that, of course, this relation always holds. Many times these mappings are created with the help of statistical analysis or statistical techniques that are applied on larger text corpora. And then, for example, of course, you have a certain probability which you can take as a confidence measure for relations you have identified there. So usually this confidence measure is expressed in a range of 0 to 1. 1 means this is absolutely true. 0 means this, of course, is never the case. And this is the confidence for that the correspondence between A sub 1 and E sub 1 and E sub 2 really does hold. So, and therefore, this quintuple asserts that the relation R holds between the two entities with the given confidence N. So this is the formal definition of a mapping. Let's have a look at some examples of mappings, but before of that, we have also take into account the complexity. So we also have referred to that we have rather simple correspondences, but they can be, of course, more complex. So first, let's start with the simple correspondences. So equality. So here we have, for example, two ontologies or two linked data sources. First, we have the DBpedia, and on the other hand, we have Freebase, another large knowledge base, and there are two concepts which are identical. You do not see that from the URI. So in one of the URIs in DBpedia, it's a speaking URI where you see that this refers to George Orwell, but you have to select the same entity wherever it's available in Freebase, and then of course you can say these two things are identical. This is the most simplest thing. Or you can say the concept author is exactly the same like the concept writer. Or you say, for example, fiction is a broader term than science fiction, and you are 100% sure about that. So these are so-called simple correspondences. The same, for example, you could say that RDFS label, this is some property that you have found in your ontology. This is a broader concept than DC title, which comes then from the Dublin core vocabulary. But probably it's not always the case. So therefore, you are only sure with a confidence of 0.9, which also means you are rather confident. But of course, things can get more complex. For example, you can change, for example, between two different kind of measurements of speed and velocity. So you can here, for example, change the unit of measurements on both sides. Or what you can do, you can really apply complex rules. So you have entities here, for example, you have X, which is a book, you have Y, which is a writer, and you have in one of the ontologies then the relationship author. So the book X is authored by writer Y. And then you can deduce out of that, for example, a new relation or a relation which is in the other ontology, which is named written by. And you can say the book X is written by, and now something, for example, a new entity which is created from the name of the author, from the name of the writer here. So this could be a more complex correspondence, which also involves the creation of a new entity or a new term that is here used in the written by relation that you see here. So this is a more complex example where many mappings between two ontologies. We have on the one hand a product, we have on the other hand something which is called a volume. And of course, these things somehow are mapped together. So these ontologies are mapped onto each other. There is an ontology alignment example, and you see here the thick arrows that point in two directions. They give the possible alignments between these two concepts. And the first one is, for example, if you look at it, we have here the book, and book is the same as volume. So product and volume does not somehow correspond, but book is the same as volume here. And for example, you could say then the ID here of that product in most cases is a more general thing than the ISBN number you have here. So this is clear, books have ISBN numbers, but other products which are not books, that they have other identifiers. So therefore it's a broader concept. And it's the same here. So you have creator and publisher and author, which are a person. And a person usually is the same here like a human. But sometimes, of course, an author not necessarily must be a person. It can also be an organization. So therefore, there are also differences. And therefore, it's only the same in 0. Or with a 0.9 confidence and so on and so on. So here, for example, name, then here, the name of a product, of course, it's a broader concept than the title, because title only reflects to book and not necessarily to other things. And author here, in both cases, where is the author? It's here. Author here and author here, both reflects to authors of books. So this is a clear identity. And what else do we have? We have here science as a category for books, and we have here essay. And they, of course, science belongs to essay, so essay is a broader term than science. So these confidences either are determined by humans, or you can also determine them via statistical processes on your available data, on the instances of the data you have. So this is an example of an ontology alignment. So two applications that take into account these ontologies then can talk to each other. They can exchange information based on these ontologies. So let's have a look at the techniques that are involved in ontology matching and ontology alignment. So here you distinguish usually so-called element level ontology matching techniques from structural level ontology matching techniques. So what is that? First, the element level matching techniques. So they usually consider the ontology entities without looking at the relations between these entities. So they simply look at the entities and compare entities in the one ontology with entities in the other ontology. And the most simple comparison technique, of course, is string matching. You simply match names or descriptions of entities, and if they really match, then you can say, yeah, they must be identical or they must be somehow similar. Then there are also linguistic-based techniques which take into account more sophisticated language processing technologies. They take into account lexicons and domain-specific thesauri, or they try to match then words based on linguistic relations. So with this, for example, you can say, okay, you have homonyms here, you have synonyms, you have partonyms. So what you can do here, you exploit morphological properties of the description within the and the names within the ontologies that have been used to deduce a relationship between the both. Then there are constraint-based techniques. They take into account internal constraints that are applied to the definitions of entities. So, for example, they look, do the entities have the same type or a similar type? Do the entities have cardinalities that are somehow inflicted on properties, or cardinality restrictions that hold for the definition of classes? And if this is the same, then you have here a constraint-based mapping. And on the other hand, they also look at the individual representation of classes. So classes will be extended. You look at so-called extensional-based matching techniques. And then two classes, for example, are considered to be similar if they share lots of instances of the class. So this would be an extensional-based technique. So these are the more simple element-level ontology mapping or ontology alignment technologies. Let's go one step further, the structural level. There, of course, we take into account the relationship among the entities with each other. So we can compare their relations with other entities or their instances. So usually these two ontologies, they are represented or can be represented as graphs. And of course, you can then take into account graph-based techniques. So you consider the ontologies as a labeled graph, and then the assumption is if two nodes are similar, then also their neighbors must be somehow similar. And then you try to prove this. Then, of course, you can also take into account the quality of these labels. So, for example, if you have taxonomic relations in there, so you consider then specializations and generalizations, and of course, you compare two ontologies based on their taxonomical relationships. Then there are so-called method-based techniques. They take into account the semantic interpretation of the ontologies. And they say, okay, two ontologies or two entities in the ontology are the same or they are similar if they share the interpretation, if their interpretation somehow is similar. So this deeply involves then also logic and logical analysis. And then, of course, you can take into account data analysis and statistics. So you take a large sample, you try to find regularities, pattern discrepancies and stuff like that, which allows you somehow a grouping or to determine a distance matrix between entities. And then you can, of course, somehow relate two ontologies based on their structural differences or structural similarities. So here you have from the interesting textbook from Jérôme Osna and Pavel Schweiko, it's called Ontology Merging. This is the textbook. There is now a new edition out of that. And Jérôme and Pavel, they have really collected all technology which is somehow relevant for this ontology matching and ontology alignment process. And they have put it here in one nice overview graphics that we won't go into detail, but here you see all these basic technologies what we have that we have referred to. So you have schema matching techniques, you have structural techniques, you have element level techniques and stuff like that, and they are all here together. And of course this can further or has been further extended since then, but you see here all techniques that are used in that ontology alignment process. So this was the mapping or alignment between two ontologies. So if we want to relate one ontology to another. Another task in the ontology development and ontology design process is, for example, if I try to combine ontologies to a new ontology. And of course, this process of ontology merging is strongly related here to that ontology alignment process. So before the end of this part of the lecture, we also talk very briefly about the process of ontology merging. So this is the process where from two or more starting ontologies, we are creating a new unified ontology. So it substitutes the original start ontologies in our new ontology. So this is often the case if you have an application in mind that, for example, combines various domains where already ontologies exist, and somehow you can then join these ontologies to a new ontology which explicitly reflects or addresses the domain or the task that you want to cover with your application. And in principle, there are two different approaches. Of course, you take into account you have two ontologies, and of course they have differences. What you can do is, of course, you can follow a so-called union approach. So there you simply try to create the union of all entities of the start ontologies. You only have then to consider whether there are some conflicts reflecting the consistency of the resulting ontology, and they, of course, they have to be resolved. So this would be a union approach. But sometimes the union approach would lead to, let's say, not satisfying results. Then you try simply to really find an exact mapping or matching between the two ontologies and try to crop out the intersection of both. So this would be then an intersection approach. So the new ontology then only consists out of those parts of the start ontologies which overlap. Then often you have the problem that, of course, you do not have an extension of one of the ontologies. You simply map different concepts with each other that share somehow their interpretation. Okay, so far so good. We have learned about ontology alignment and ontology merging. And if you now have nightmares about your created ontology, of course we must have means somehow to consider the quality of a created ontology, and this we will address in the next part of the lecture, which will focus on ontology evaluation.